Hey, hello my dear friends, welcome to my channel. Here I'm going to show you one beautiful video lecture series of my soft computing. So basically we are going to see my soft computing. So let me zoom it. So in soft computing we are going to see first what is my control law. My control law means if you call this my y is equal to f of x, means y is my function of, with this my function, or I call this as commutation also, y is a function or commutation of x. Okay, so this is my control law. Then after that, before seeing soft computing, what we'll see is what is meaning of my hard and what is meaning of my soft. Okay, let me change the color of the pen. If you see my hard computing, if I talk about some signal, let us consider this signal. It is varying from 0 to 1, means it has value either 0 or 1. Okay, it doesn't have value between these two. It has value 0 or 1. So this is called my soft computing. This is called my hard. If I talk about soft, it has value between 0 to 1. 0 to 1, 0, 0 0.1, 0 0.2, including 0 and 1. This called is my soft. Fine. So before seeing soft computing, I'm going to show you what is my hard and what is my soft. Okay. Then what is my system? System, there are three types of systems. One is my linear system, then second is non-linear system, third is my dynamic system. In linear I have time invariant, then time variant, and this is my time variant, time invariant, same in case of non-linear, and one is my dynamic system. If I talk about linear systems, what is my linear systems? Linear systems has two equations. Let us see these two equations. If if I do by mathematics, my equation solutions are such that it is not coinciding. So this is my no solution. If it is coinciding and has one crossover, means it is crossing and it has only one cut, so we call it as unique solution. If it is such that it is like this, so there is infinitely many solutions. Fine. So then is my linear system. If I say my linear system, it has solution or it has no solution. If I call it has a solution, so I have answer, it has solution, then what is it's a unique solution or infinite many solution. If it is a unique solution, then find the condition where I can get that unique solution, then find that solution. Same infinite many solution, I will find that condition in which I am getting that infinite many solution, then I will choose the best. Okay, how I will choose this best? I will choose this best by doing my soft computing. Okay, how I will choose this best? I'll choose this best by using my soft computing. Fine now. Then I have my system. If it has no solution, if my system has no solution, then how can I find this? I can find this either it's a singular value decomposition, then I will take directly as an inverse, or it's by least square solution, means it has some error. Means in this also unique solution, if it has a solution, that is fine. If it has infinite many solution, same in this also I have to use the best solution by using my soft computing. In this also unique solution, I have to use my soft computing to find that error, which is a minimum error, least square solution. Fine now. If I say it has a no solution, if I say I have what? No solution, then how can I say let x is my some image, this I need that y as a same image. What I use, I will first put this in encoder, then after that at the receiving side I will put one decoder, then this part is my a. If I take this error, means output minus input is some error. Error is so much, like if I put image of human, I will get image of cat. It doesn't look like cat, but it is a cat. It's a huge error. So it is a no solution, because I'm giving the image of human, I'm getting the image of a cat. Let's see next. Then see soft computing. What is my definition of my soft computing? Fine. So it is given by L.A. So it is collection of methodologies that aims to exploit the tolerance for imprecision and uncertainty to achieve what? Fractability, robustness, and low cost solution. So basically what it is, if I talk about fractability, robustness, and low cost solution, what it is? Fractability, if I talk about, it is that follows the input, it will follow directly to the input. Robustness, if some small disturbance is there in input, like my X is my input. If I consider this, my noise has also established my input, like in my headphones some noise is there. So my speaking, some noise is there, it should not be audible to you, means I have removed, my system or my software which I'm using is robust. Okay, it is robust so that you are not able to hear that noise. So my system is robust. Fine. Then after that soft computing, I will see what is my hard computing. In this soft computing, what we saw that it is imprecise, uncertain. Okay, in this what it would be, it is precise. What I told you earlier was 0 and 1. There are two things. 1 minute. There are two things, that is 0 and 1, means it is precise. It is between 0 and 1, means between so many values are there. So this is what we call as imprecise. Hard computing is my precise result. It gave control law which is used. It is unambiguous and accurate. It is much more accurate than it is used in soft computing. Whereas soft computing is giving what? Uncertainty and imprecision. Fine. The control law has to be mathematically defined. In this, as per no mathematical design, means deterministic in case of hard computing. Then there are different parts of soft computing, like it is a fuzzy logic, neural network, and probabilistic reasoning, that is my genetic algorithm. If you talk about neural networks, okay, neural network has learning based on supervised learning and unsupervised learning. Means supervised means this is, let us consider you, student, and to every student there is one teacher available. This is my supervised learning. Unsupervised learning, it is learning by its own. By its own means, like if you fell in some pit, some pit is there on the road. If you fell because you are using your phone, so next time you will when you're using your phone, you will be careful, because you have already learned that if I use phone, I will fall in the pit. So this is called non-supervised, means no teacher is available, but you are learning on your own. Fine. So next, see what is my fuzzy. If I will come, what is my fuzzy? Fuzzy is it is not proper, it is not exact. Okay, I can say I will come. When I will come, I don't know, so it is vague. I will come within 5 minutes. When within 5 minutes, I also don't know. This is my fuzzy. I will come within 5 minutes after 3 p.m. This is also fuzzy. Let me tell you about doctor-patient relationship. Why is f of x? Means how doctor will tell which medicine to give. Fever plus cough. So this is a patient. It came to the doctor and told, doctor, I have having fever and cough. So he will give then medicine. He will check whether he is having corona or not. Then he will check the symptoms. What is my symptoms? He has fever, he has a cough. Then he will test it. So this is my input, this is my output, this is my system, f of x. This is my normal system, what I was telling you, y is f of x. Okay. Then we will see fuzzy logic. Fuzzy logic, it's a mathematical language based on set theory. Like we have C, C++, we have Java, we have Python, all languages. These all languages have its own syntax, semantics, and grammar. In this fuzzy logic, I have its syntax based on my set theory, fuzzy semantic based on my fuzzy controller and developer, and my grammar based on the fuzzy rules. So first, see algebra. There are three types of algebra. We have relational algebra, in which I have my intersection and union. Second is my Boolean algebra, in which I have and, or, and so on. Then third is my predicate. In that predicate I have differentiation and integration. Fine. Let's see what is my crisp set theory and what is my fuzzy set theory. Okay, let me take pen. So what is my crisp set theory and what is my fuzzy set theory? So crisp means it has either 0 or 1, means yes or no. How? This is my system. Input is my Coca-Cola. I will ask my system whether Coca-Cola is colorless or not. Okay, answer can be either 0 or 1. If I ask you whether Coca-Cola is colorless or not, either answer is yes or no. So this is my crisp. I have answer, definite answer, means it is accurate, 0 or 1. If I ask, let us consider this is you only who is watching the video. Well, I will ask in the system whether you are honest. Okay, whether you are honest. Answer can be extremely honest, very honest, honest, dishonest, and extremely honest. Fine. So if I talk about extremely honest, it is 0.9. I will give. Extremely dishonest, I will give at 0. Dishonest 0.1, and increasing on. So this is my fuzzy set theory. Fine. This is my fuzzy set theory, and this is my crisp set theory. In crisp set, I have 0 or 1, means either yes or no. In fuzzy set theory, I have between 0 and 1 so many values. Then I have my set theory. As we already studied what is my set theory, so I'm not going to tell you what all is this all about. So I'll tell you basic. We tell you how to define my set. Okay, this is my some main block where my total system is there. This is my system for A. Sorry, let me take a pen. This is my total system. Okay, this is my system for A, in which it is male, and this is my female. How can I define this as union, intersection? All we can tell in this system. Okay, we will already see in further videos how it is. It is basically crisp set. How we are going to perform in this crisp set, we'll see. Then if we define my system, let's go to here, this part. So this part I will tell you, this is my crisp part, as I already told. So in crisp part is basically like normal set, like x1 pointed. This basically like my fuzzy set only. How this is my fuzzy set, I will tell you. Wait 1 minute. This is my fuzzy set. Fuzzy set, how we can define my fuzzy set? Fuzzy set, I can define x1 with some measurement. This is my weight, some measurement of this x1. Like if I tell you by some example, like today's temperature. Okay, today's temperature x1, like it is very hot. Very hot means I can take it as 1.1. If I will tell you then next day temperature, this is 0.2. This is means somewhat little more better. X3 0.5, this means warm. Okay, then so on. I can take this as cool as my 1. So like this, my temperature is varying for 1 month. This is my fuzzy set for 1 month. So if I take this, 1 minute. I take this my system as ordered pair. Fuzzy set is my ordered pair, in which I have this pointed as my measurement. I represent this by a bar, where x1 is my element and g of x1 is my membership value of which is represented by mu of a bar of x1. What is my x1 is my element. Okay, if I define this a bar, it's my x comma membership value of x, where x belongs to the capital X. X is my universal set. Like in set I have x, or I call this as E also, like my universal set. Fine, I will stop my lecture here. In next part, what we are going to see is my linguistic variable. So we continue in the next lectures. Thank you guys. If you like this video, you can subscribe my videos. Thank you so much.